Hello viewers, I am Kausalya. Today we are going to discuss about theorem 10.2 and this theorem is also known as equal tangent lengths theorem. So here the statement is the lengths of tangents drawn from an external point to a circle are equal. Right. So here this is our circle, right? This is the circle and to this circle we are having an external point. Okay, let this point be P. Right. So the length of the tangent drawn from an external point. So this is the point. From this point we are going to draw two tangents. Right. So this is one tangent and this is other tangent. And what we have to prove? That is the length of the tangents are equal. Right. We have to prove that the length of the tangents are equal. So here in this diagram we have drawn a circle and we have drawn two tangents. Right. Now let O be the center of the circle. So just we are drawing radius, that is R. Okay. In such a way, you see it meets this point B as well as this meets point A. Right. Again from this point O we are drawing a line such that it joins P. So you see P is the external point and we are having a circle with center O and radius R, and PA and PB are the tangents to the circle at point A and point B. So here we have to prove that PA is equal to PB. Right. In order to prove, we are joining all the points. Okay, we are joining OA, OB and OP. Right. So here now we are going to prove that PA is equal to PB. So the first thing we are considering here is, you see, angle OAP is equal to OPB. So let's check. First let us examine what is angle OAP. So when you look at this diagram, you see OAP. Right. So what is the angle here? Just now we have seen in our theorem 10.1, right? So the angle between the radius of the circle and the tangent is 90 degrees, or in other words, the radius and the tangent are perpendicular, right? So OAB is 90 degrees. In the same way, OBP is also 90 degree because again this is your radius and this is the tangent, right? So that is the reason here we are writing OAP is 90 degrees and OBP is 90 degrees. So just write it. Right, this is because due to tangent radius theorem, or else better even you can write the statement. Right. Now the next thing is we are going to consider the right angle triangles OAP and OBP. Right. So again we will go on examine. You see what are all the two triangles here? So the triangles are OAP. Okay. This is one triangle and OBP is another triangle. Right. Now we are going to take these two triangles. So when you consider these two triangles, you see, shall I draw it separately or let us continue here? Is it okay, right? OAP is one triangle and OBP is another triangle. So when you examine these two triangles, you see the side OA is equal to OB because both are the radius of the circle, right? That is our first thing. And next, when you consider these two triangles, the side OP is common for both the triangles, right? OAP, when you take the triangle OAP, we are having the side OP. Similarly, when you take the triangle OBP and again OP is common, right? So here we are having, you see, OA is equal to OB because it is the radii and OP is equal to OP because this is a common side, right? So by RHS criteria of congruence of triangles, right? So here RH is nothing but right angle hypotenuse side criteria, right? So based upon this criteria, you see triangle OAP is similar to triangle OBP. Right. So this means that the angle, that is the length of the tangents, PA is equal to PB. Right. So here the thing is, right angle hypotenuse side criteria is nothing but, right, one of the angle should be 90 degrees. Okay. That is, we are considering two triangles, right? Now we have considered this triangle and this triangle. So in these two triangles, right? So here the angle A is equal to angle B because both holds 90 degrees, right? And similarly, the side OP is common, okay? In triangle OAP, there is a side OP, and similarly OBP, there is a side OP. So an angle and a side of one triangle is equal to the angle and side of other triangle, provided both the triangles are right angled. Right. Under such condition, we can define that the other side, okay, PA is equal to PB. So, corresponding part of the congruent triangles are equal. Right. So, finally, we have proved that the length of the tangents drawn from an external point to a circle are equal. Right. Here, the main thing to be highlighted is RHS criteria of congruence of triangles. Right. So when you take two triangles, right, here we are comparing two triangles. Wait, let me draw that also so that you will be having a clear idea. So now consider the triangle APO here. Similarly, consider the triangle OB and P. Right. So in these two triangles, you see angle A is 90 degrees and here angle B is 90 degrees. Right. And in these two triangles, we are having the side, okay, OP as common. Right. So this triangle has OP, and similarly this triangle also has the same OP. So you see, whenever you are comparing two triangles, okay, they are right angled. Okay, they are right angled and they have one side common. So then we can say that the two triangles are similar. So this is what RHS criteria says. And here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.